Welcome students and friends. In this video I'm gonna give you two examples of finding the derivative of two functions that requires to use the chain rule. So let's get started. The first example is gonna be the function y equals ln of ln x. Alright, so we know that chain rule basically you use it when you have a function inside another function. So basically, when you need to take the derivative of a function that has an inside function, then you need to use the chain rule. So for this example, what's the derivative? So the chain rule says that the derivative of y prime, or dy dx, is equal to the product of the derivative of the inside times the derivative of the outside. So what's the derivative of the inside? What's the derivative of ln of x? That's gonna be 1 over x times the derivative of the outside, which is ln of x, 1 over x. But remember, in this case, we have we don't have x here, so we need to put whatever is inside the inside function for. So in other words, ln, the derivative of the outside, is ln 1 over x, but because we don't have x, we have to put whatever is inside, and that's what we put here. So now we combine terms, and we have 1 over x ln of x, and that's gonna be our final answer. On the next example, we're gonna look at a little more intricate function. We're gonna do the following function. In this function, we're gonna have to use two things: the chain rule, and also we're gonna have to use the quotient rule. So this one is a very common problem. Okay, so let's see: e to the x squared over x. Okay, notice we have a quotient. What that tells you is that we need to use the quotient rule if we want to make it easy. But we have an inside function for the top part, so that means that we need to use the chain. So here we're gonna use the chain rule. And because of the quotient, we're gonna use the quotient rule for derivatives. Okay, so now the quotient rule says that y prime, or dy dx, is equal to two things. The bottom part is gonna be x squared, because it takes the top, the bottom, and squares it, so that's gonna be x squared. And the top part says that we're gonna take the top part, we're gonna take its derivative times the bottom. Okay, so the bottom says that is x, and then we multiply times the derivative of the top. So what's the derivative of the top? We need to use the chain rule. So first, okay, so what's the derivative of e to the x squared? It's gonna be okay, first take the derivative of the inside. So x squared, derivative of x squared, 2x times the derivative of the outside. What's the derivative of e to the something? It's just e to that something, which is e to the x squared. And then we do minus, and now we do the opposite. We take the derivative of the bottom, which is, what's the derivative of x? Just 1, so we just leave 1 times the top. Okay, we can simplify this by multiplying the top of the top things. Okay, it's gonna be, so first we can cancel this one, we leave an x. Let's see, 1 second. Now we take x. Okay, so now to make it simplify, we leave x, and then this x here we can cancel it here, but this x square has to, okay, I'm not gonna make it too complicated for you. Let's make it easy. One way to do it is as this. Okay, let's leave the x square, leave the 2x here. One way to do it is as follows. We expand this first, so that's gonna be 2x squared e to the x squared minus e to the minus x squared, t to the x squared, all over x. Then what we can do to make things simpler is we can factor out an e to the x squared. So we're going to leave the top as e to the x squared, and then on parentheses we're going to have 2x squared minus 1 all over, remember this was x squared, and this one was x. Yes, yeah, now we simplify it, 2x, this was x squared, yes. Okay, so now 2x and then 2x squared here. So that's equal. Okay, we can further simplify this as follows. We can simplify, cancel these things out here. Okay, so now this one was x squared. Okay. So now this cancels with this, and then we're gonna left with e to the x squared. Then we have 2 minus x to the minus 2. Because this one cancels with this, and this one 1 over x squared becomes x to the minus 2. If you don't want to have negative, because some teachers they require that you don't have negatives, you can leave it as follows: e to the x squared, e to the x squared, and then you put 2 minus 1 over x squared. So either way is correct, and this will be the final answer, the final derivative solution. So thank you very much. Don't forget to subscribe, please.